So you get the natural reflections, you get natural refraction of light, and that all bounces through the scene, and it just gives a much more sort of natural look. It's really exciting because it's going to give a level of realism to our lighting that's never been seen before. If sci-fi was the first wave of virtual production, where we needed to imagine impossible worlds on a screen like that, I think the second wave is really driven by being able to transport you to anywhere.
All right, virtual production, LED walls, that's the hot topic this time.
Yeah, it's really changing the game, isn't it? Getting those in-camera visual effects, that ICVFX look. But it's not without its challenges.
No, definitely not. And one of the biggest ones, the one that really makes you scratch your head, is blur. Or should I say realistic blur?
Ah, yes. Depth of field. It's something we take for granted in traditional filmmaking, but when your background is a giant LED screen, well, it gets tricky.
It's like, imagine you're watching a movie and the main character's in focus, but the background has this nice, soft blur. Now picture that same scene, but it's shot on an LED volume.
And that's where we run into the double blur problem. You've got the LED wall, which is already displaying a rendered image, often with its own simulated depth of field.
Right, so you're saying it's already got some blur baked in.
Exactly. And then you bring in the actual camera with its own lens, and you're applying a second layer of blur on top of that.
So it's like blurring a blur.
Precisely. And to the untrained eye, it might not be super noticeable, but to a cinematographer, it just looks wrong. It feels unnatural.
Yeah, like something's just a little bit off.
And Ben Kidd from Epic Games, he really dove deep into this problem for his Unreal Fest presentation. He was determined to find a solution.
I heard he spent countless nights in the office just staring at blurry barrels on LED walls, trying to figure it out.
Chuckles. Well, it certainly captured his attention. And the challenge was, how do you fix it? Turning off depth of field completely wasn't an option. It just looked flat and unrealistic.
Right, because then your foreground objects would be weirdly sharp.
Exactly. And if you just tried to match the real camera settings to the virtual camera settings, well, everything just ended up looking like it was shot through a Vaseline-coated lens.
Yikes. Talk about a blurry mess. So what do? You can't just tell the camera to ignore the fact that it's filming a screen.
That's the thing, isn't it? It really made them think differently, more fundamentally, about the nature of blur itself.
So where do you even start with a problem like that? How do you unblur the blur?
It all starts with understanding how blur actually works, how it functions on a fundamental level.
Okay, getting technical.
I like it. And the best analogy for this, believe it or not, is a magnifying glass.
A magnifying glass. Like the kind you used to burn ants with.
Exactly. But in this case, we're not burning anything, I promise.
Okay, good to know.
Think about how a magnifying glass focuses light. You can take those rays of light and make them converge into a tiny, super bright point.
Right, the focal point.
And that, my friend, is essentially the circle of confusion.
The circle of confusion, that sounds ominous.
Not really. It's just a fancy photography term. It refers to the smallest point of light that a lens can focus.
So smaller circle of confusion, sharper image.
You got it. And a larger circle of confusion translates to more blur.
Makes sense.
Unreal Engine, just like other rendering software, uses this concept of the circle of confusion to calculate and simulate depth of field in its virtual environments.
Okay, so back to our LED wall problem. How does this circle of confusion tie into that whole double blur thing?
Think about what's happening. You're essentially pointing a camera at another camera, in a sense. The LED wall is displaying a rendered image, right?
Right, and that rendered image already has its own calculated blur, its own circle of confusion.
Exactly. So when you film that with a real camera, you're adding another layer of blur, another calculation of the circle of confusion on top of the one that's already there.
Ah, I see where you're going with this.
Yeah.
It's like putting on two pairs of glasses at the same time. Things are bound to get blurry.
Precisely. And that's what they had to figure out, how to fix, how to reconcile those two different calculations of blur happening simultaneously.
So they've got this double blur puzzle to solve. What'd they do, invent a whole new camera?
Not quite, but close. They went deep into Unreal Engine and, well, they got creative.
Creative? How so? Did they hire like a blur whisperer or something?
Not quite. Think more along the lines of some seriously clever programming. They found a way to basically counteract that extra layer of blur.
Counteract? So like fighting blur with blur.
It's more like predicting and then adjusting, all in real time. They basically taught Unreal Engine to anticipate how the camera's blur would affect the image on the LED wall and then compensate for it.
Wait, so it's adjusting on the fly?
Exactly. And they did it by using what's called a lookup table. Essentially, it's a pre-calculated set of data that tells Unreal Engine exactly how to adjust the blur based on the specific camera settings, lens, and even the distance to the LED wall.
A lookup table. Sounds kind of old school for something so high-tech.
Maybe, but it's incredibly effective. Think of it as a cheat sheet for Unreal Engine, allowing it to bypass all the complex calculations it would normally have to do in real time.
Okay, now that's clever. So no more fiddling with settings every time the camera moves an inch.
Nope. It's a dynamic solution, meaning it adjusts automatically. Move the camera closer, change the depth of field, whatever you do, Unreal Engine adapts and makes sure that blur on the LED wall still looks totally believable.
And this is all thanks to that Unreal Fest presentation by Ben Kidd, right?
Yeah, he and his team deserve a round of applause. They really cracked the code on this one.
Here's our double blur, as we saw before. Here's our no blur, so you can see how much of the background we've destroyed. And then here's our compensated shot. So you can see there's some changes there. We described, you know, there's some limitations in the amount of blurring that you're going to get still. But generally speaking, is a good match. So, how do you use this feature? Well, switch it on.
Unreal Engine 5.4 and every version since now includes these tools to practically eliminate the double blur problem.
No more blurry barrels, huh? But what's really exciting is what this means for the future of virtual production. It's like we're one step closer to those completely immersive, hyper-realistic experiences.
Exactly. The possibilities are endless. Imagine creating fantastical worlds, impossible camera moves, all without the limitations of traditional filmmaking. And it all comes down to understanding the science of blur. Who would have thought, right?
It just goes to show that sometimes the most groundbreaking solutions come from revisiting the fundamentals. Thanks for taking this deep dive with us. I can't wait to see what visual wonders the future holds for virtual production.